Hey pilot aspirants, so today we are going to discuss our aviation metrology paper. So in that paper we want to know about the book written by I.C. Joshi sir, that is Aviation Metrology. So I think in many of the local states or local shops we are not able to find the needed textbooks for DGCA. So that is the main reason why I started a channel like this, because during my preparation journey also I find it very hard in finding some materials to look on. So to explore materials is very important, right? So that's the reason for this. So today we can go through the aviation metrology paper, and for that paper you should be thoroughly gone through a book known as Aviation Metrology by I.C. Joshi sir. So let's start without any further delay. So first chapter, as you can see, it is the atmosphere. So first, atmosphere. So in this chapter we will mainly discuss about atmosphere. So you know, atmosphere is just a layer of gases which is enveloping the earth. It surrounds the earth and is attached to its due to earth gravitation. So why the atmosphere is attached by earth? It is because of its gravitation. The earth moves with the earth at same speed and direction. It appears to have no limits. However, a very large portion of atmosphere is confined within a few kilometers of the surface. Now, characteristic atmosphere has weight and hence exerts pressure. It is compressible and expandable. It occupies space and has no definite shape. It is mobile, in which transfer of heat and moisture occurs. Now, composition. Air is a mixture of gases. For all practical purposes, dry air is a uniform mixture of following gases. So you can go through the percentage, because while looking the questions of this chapter, it is mainly carbon dioxide. So what is the percentage of carbon dioxide in air? So it's a question which has asked. So it is 0.035%. As you know, DGCA has negative marking and it's all about MCQs. It's all optional questions. It's all right, but there is negative mark, and one of the options for this was 0.35, 0.0351, and the other one is, means everything is matching, so there is a major chance to get confused between that. So you should be clear on what you have looked. So nitrogen 78.8%, oxygen 20.95%, argon 0.93%, and carbon dioxide 0.035%. Then traces of neon, helium, methane, krypton, nitrous oxide, hydrogen, ozone, and xenon. Ozone എന്ന് പറയുമ്പം 0.00005 zeros ആണുള്ളത്, 7%. So that's it. Now next, nitrogen and oxygen constitute. So this was also a question. So nitrogen and oxygen constitute about 99% of air. So when I look through this on my time, that I have learned in my schoolings that nitrogen of 78%, oxygen of 21%, and the remaining 1% is comprised of other traces. But it's not like that. You should be accurate that 78.808% nitrogen and 20.95% of oxygen, and the remaining, it's not all the remaining constitute, and a major portion in that remaining is constituted by carbon dioxide, that is 0.035%. Okay, so you should know that. Now by looking this ratio, you are clear that nitrogen and oxygen constitute the 99% of the air. So their proportion is nitrogen oxygen by volume, it is 4:1, nitrogen oxygen by weight is 3:1. So during my time I used a small trick. I don't know whether it works for you too. So I just say it as NO4V. V and NO3 weight. So anyway, there is no confusion for me that one is 4:1 and the other is 3:1. Nitrogen is to oxygen ratio. So one is whether it is weight or volume, that is what confusing me. So nitrogen is to oxygen composition. So it is by volume it is 4:1. So what I use is NO4V. So it is okay. NO4V. That is nitrogen is to oxygen 4:1 V volume by volume. So that is a trick which I used. So hope if you try it useful, you can mark that. So NO4V which means nitrogen is to oxygen 4:1 ratio by volume. So the remaining by weight it is aware on me because I know the other is third is 3:1. So due to rapid reduction of gases with the height, supplementary oxygen is needed about 10 feet. So it is also a question above how much kilometers or above how much height oxygen, supplementary oxygen is needed. So it is 10,000 feet. You should also be known about this SI unit because your options will be given as 10,000 feet, 10,000 meters, 10,000 centimeters, something like that. Maybe everything finds the same for you. So you should be, yes, you should be known that above a height, with height, supplementary oxygen is needed about 10,000 feet. The atmosphere is generally well mixed. It has a near similar composition up to height of 80 kilometers due to earth gravitation. The atmosphere up to 80 kilometers is known as homosphere and above it is known as heterosphere. At about 20 to 25 kilometers, there is a high concentration of ozone. So, homosphere, we divide the atmosphere firstly on the basis of the height, that is above 80 it is heterosphere, below 80 it is homosphere, because as Earth's gravity, as we know that atmosphere is surrounded or it is it's not balanced, that atmosphere or the earth is surrounded by atmosphere because of the gravitation. So this gravitation is extending up to a height of 80 kilometers. So up to 80 kilometers nearly similar composition of atmosphere is found. So up to that it is known as homosphere and the remaining it is known as heterosphere. Now yes, around 20 to 25 kilometers there is a high concentration of ozone. Now important variable gases. In addition to the above gases, atmosphere also contains water vapor, carbon monoxide, sulfur dioxide and nitrogen dioxide. These gases vary in amount from place to place, being concentrated more in industrial areas, cities like heavy vehicular traffic, water bodies etc. than in open area. Though very small in quantity, water vapor, carbon dioxide and ozone are very significant for weather and life. They causes a greenhouse effect which keeps the earth warm. These gases are also known as greenhouse gases. Ozone protects us from the ill effects of ultraviolet radiations from the sun. So water vapor, carbon monoxide in our atmosphere is present. Now carbon dioxide, ozone. So these three gases are known as greenhouse gases. Okay, greenhouse gases. What is greenhouse effect? Yeah, heating of that is what you know. Yes, you have learned in your schoolings, right? Yeah. So even though the quantity, the availability is very low in percentage, it is very important for weather and life. Also ozone, as you know, it protects us from the sun. The ultraviolet radiations of the radiated from the sun. Ozone protects us. Now, so this video will be quite lengthy because we will cover the whole chapter in a one, because it's not too long chapter. It's a simple chapter which is easy to read and go. So we can, I think it is better to conclude in a one video. So dry air and saturated air. Coming back. So dry air and saturated air. Before going to theory, let me say what is dry air and saturated air. So when the water vapor, the content of water vapor is 4%, that kind of air is termed as saturated air. And when the humidity is less than that, it is known as dry air. So water in the atmosphere can exist in three states, right? Solid, liquid and gaseous. Solid state snow, ice, hail. Liquid state drizzles, rain, shower. Gaseous state water vapor. The concentration of water vapor rapidly decreases with the height. As you know, why it decreases with height? Yes, the amount of water vapor that air can contain largely depend on temperature. Warmer air can hold great amount of water vapor. So, the water vapor content in a warmer place is greater than that of a cold place. The water vapor amount can be much as 4% in tropics and about negligible in polar regions of higher altitudes, about 30,000 feet due to very low temperature. So, as temperature decreases, the water vapor content also decreases because warmer air can hold much water vapor. Okay, so that's the reason. That is in tropic region where there is a warm condition or where the temperature or weather is warmer, there the water vapor present, there the 4% of water vapor can be found in tropic region, and with 4% water vapor the air is termed as saturated air. Has 100% relative humidity. When relative humidity is less than 100%, the air is unsaturated and is called dry air. Okay. Yes, so that is what dry and saturated air, saturated or unsaturated air. Now, carbon dioxide. Carbon dioxide is produced by burning of fuel, wood, etc. Its concentration is substantial in industrial areas, where in polar regions and higher altitudes it is negligible. A large amount of carbon dioxide is dissolved in ocean. Plants absorb carbon dioxide, use it carbon as food and release oxygen into the atmosphere. Now, ozone forms in the upper atmosphere. It absorbs ultraviolet radiations from the sun and raises temperature. Ozone molecules then become heavier and sink and accumulate in the lower layers. Appreciable ozone is found between 10 to 50 kilometers with maximum concentration at 20 to 25 kilometers. This is what we have already said, right? Yes, 20 to 25 kilometers lana ഏറ്റവും കൂടുതൽ ozone present ആയിട്ടുള്ളത്, and more than that there is ozone is found between 10 to 50 kilometers, and where the high concentration is between 20 to 25 kilometers. Now, ozone hole. In recent times, ozone layer has thinned and large holes had developed mainly over the polar and other latitudes due to atmospheric pollution and excessive use of chlorofluorocarbons. CFCs emitting sources are refrigerators, air coolers. These are the main sources of CFCs, right? So, CFCs and atmospheric pollution. Atmospheric pollution can be of any type, right? Soil pollution, air pollution, water pollution, metal pollution, non-metallic pollution. Many kinds of pollutions are there. So, in this modern world, pollution is a big taboo. It's like a danger in our world. Solid particles. In addition to the above gases, the atmosphere contains particles such as salts from evaporating seawater, dust from arid regions, industrial and similar other particles. They obscure solar radiation and affect visibility and temperature. They also act as nuclei which promote condensation of water vapor prematurely. In larger cities and industrial areas, frequent fog and smog and a mixture of fog and smoke, which is termed as fog and smoke. I think it is smog. It is smog. That is a combination of fog and smoke. Fog and smog is due to high concentration of such particles. Greenhouse gases, water vapor and carbon dioxide absorb certain wavelengths of terrestrial radiation and re-radiates them towards the earth. They causes greenhouse effect which keeps the earth warmer than it would have otherwise be. Water vapor, carbon dioxide, ozone and some other gases are called greenhouse gases. They are causing global warming, which is a serious threat to our life and needs to be limited. Vertical distribution of air masses, we can discuss that in our next session, because otherwise the video will be quite much more boring. So these are simple points that we have already learned in our schoolings and all. So I am concluding this video with the minutes of 15 minutes, and we can continue in our next video, and the questions from this can also be answered in our next video. Thank you.